Let us talk electrical works to this topic. Uh, According to the guiding principle, which is the standard method of measurement, we're expected to price electrical work per point. That is the power and the lighting. We're expected to price per point. And in doing so, it is expected of us to build up our rates to include everything that will take light from the dB to those points and make it work aside from the dB. So in doing so, what we're expected to consider is the piping, the cable, knockout boxes, consumables, which are the bushes and the coupling. So those items are the things that you needed to include in that price of that point. And I am going to guide us on how to eventually make it a point. First of all, I will first build up my rate in meter. Then we'll now go to why it now became a point. As you can see here, I have the unit rate for a 1.5. I have a unit rate for a 2.5. I have a unit rate for a 4 mm. I have a unit rate for a 6 mm, and I have a unit rate for a coax cable. Then have unit rates for armored cables 4 by 120, 4 by 35, 4 by 5 by 16, 5 by 10, 3 by 1 armored cables. So what I did is for me to price these items in meter, and in meter I am getting the cost of 631 for 1.5. Please let us be aware that these rates are not current rates. The only thing that can now change this to current rates, it is you now going to, these are the rates you are seeing, and it is you now going, because first of all, let me tell us how you can see what it's on this on the screen. This rate is coming from my schedule of basic rates. I divided it by 25 by 20 and divided again by 2.1, meaning that I went to the market, asked for a price of a bundle of PVC pipe. The height of those pipes are 2.1. They told me a bundle of 25 is a certain amount. Then I now said that bundle of 25 the amount divided by bundle of 25, then divide it by one of the pieces. Then it gives me the cost per meter. And the same thing equally I did for cable. For power, it is you need two cables, the supply and the neutral, to give it to make that socket, that switch work. So that is why you are seeing 2 meters here by the cost of the 100-meter cable divided by the cost divided by 100 gives me the cost per meter, multiplied by 2 meters, which is neutral, and the power, the supply, gives me this. Then for the knockout box, of course, it is 1 at 300, multiplied by the gives me 300. Then the consumables, if you keep your cost data from various sites you've worked, you'll be able to apply a reasonable percentage and it will work. Why am I saying so? Say I have built a duplex and the cost for the couplings, the bushes, and all of those items is a certain amount. And the cost of the whole pipes that I have used to pipe that building is a certain amount. And I want to know what the cost, what percentage is the cost of the coupling to the pipe. Once I get that, I can apply it for, if I have done that constantly and I'm having, within, say, I have done it for project A, B, C, T, and I'm getting, say, a 9% is the average percentage of the cost of the couplings, the bushes to the pipe. Rather than me going to say I am going to say, okay, for each of the knockout boxes, we're going to have a bushy, we are going to have a coupling, we are going to have all of that. I'll just apply that percentage to the cost of piping, and it gives me the cost. So by the time this 12 naira you're seeing here multiplied by the numbers of points, it will give me the amount that I can buy bushes and couplings and other things that I can use to with the Y boxes and U boxes and all of that that I'm going to use to to pipe the whole of that building. So I have applied this 10% to the cost of the piping, and I am now applying 2% of the whole of this cost for my transport. Of my transport of all of this material, I'm applying 2%. I have 11 naira. So when I sum this together, it gives me a 601 naira per meter. Then I apply 5% waste. Definitely, I'm going to record waste in cables and in piping. So I apply 5% to the cost. I came to 631. Then we'll go back. We'll discuss how I came to the cost of 4,402 per point. And why is this 7 meters here? It is me now multiplying this one, this cost per meter by 7 meters gives me the cost per point. And at the same time, the same thing, this is a 120 cost per meter for labor, multiplied by 7 gives me the cost 840 per point for labor. So for me to get the cost per point is this plus this gives me it gives me 5,260. Please, there is a warning that these rates are not current rate. So I did say that I was going to take us to our basic rate to see how the rates came about, and I did. So as you can see here, I have electrical works. It is always very good as a quantity surveyors to have a unit rate bank where you have all your unit rate. Like for here now, I have my unit rate for civil works, which is cost of labor, cement, granite, sharp sand, stone dust, imported laterite, pesticide, polythene, 100 micron planks, timber. I have the section for paving. I have the section for roofing, the 50 by 75 timbers. I have the section for doors. I have the section for office partition, toilet cubicle, painting, tiling sections. I have the section for window, casement, sizes of windows and all. It's just for me to ask the specialist what is the prevailing cost for this based on the specification of the architect for whichever cost I am pricing. Then as soon as I get it, I put it here. It gives me a unit cost. I have for doors, I have for steel grills, I have for fitting and futures, electrical works. So now, like I did said, as you can see, I have 20 PVC piping for that, and it's 25 in a bundle, and the cost is 6,500. And that rate says, the rate now says, the basic rate, which is 6,500 divided by 25, give me the cost of one. Then I now further divide that cost of one by 2.1, which is the length of one pipe. Then it gives me the cost per meter. The same thing for the electrical works. Electrical works, you can see I have a 1.5 cable. A roll of it is 100 meter, is at 7,670. Then I divided it by I divided it by 100, and I'm having the cost per meter, and I multiply by 2, I have this. So it is the same principle that is applicable to all. The only difference is this one that will differ from one to another. And why it will be different from one to another, let's go to a typical drawing to illustrate that. As you can see, for power, the cables are looped from one socket to another, looped from one socket to another. So what I need to do is to measure this cable. And how do I measure this cable? Because if you're given a bill and you're not given the drawing for you to determine that, it is only if you can appreciate that kind of building, and maybe over time you've been able to measure such building, you can as well now say, okay, the average meter for to supply one point is so, you can apply it. But it is always good you measure to know. I'm giving this drawing. What I need to do is I have a supply coming from this point to this point. I know this socket is going to be, say, a 500 above the floor level, and the building is a 3-meter height to the ceiling. So I'm taking 500 out from the 3-meter. It takes me to the inside the ceiling. Then I measure, if I'm taking it straight off like this, because mostly this curve doesn't apply. This curve does not apply. If I'm taking it straight this way, I take it this straight way, I returned it down into the the socket here. Then if I needed to break this wall at the 500 level to link to this one, then take this one up again and bring it to this one and drop it inside of this one, I will do. So it is based. That is why it's always very good that even though your core competence is a quantity surveyor, you should be able to understand understand how this things you are measuring, how it's being applied on site, so that if you're given half information, because of the experience you've gathered, or you've been able to see the guys doing the job on site apply, you can apply it during the course of your measurement. Now, this is a twin, a semi-detached. This is semi-detached. So let's dwell on one of the detached. So after measuring all of this cable, and I will now count the numbers of the number of sockets I have here, I will divide that the linear meter I have here by the number of points. It will give me what will be the average length for each of those points. So once I get the average level, let's say here now I was able to get, after measuring the cable that takes current from each of those points to another, and I got, say, 100 meters. So what I now do is I'll now say 100 meter, and I got maybe the points are 10 points by 10. It gives me 10 meters. So what I'll just do now is just to put 10 meters here, 10 meters here. It gives me the cost per point. Then the cost per point is now 9,409 plus 3,000, which is the cost for the labor. It gives me it gives me it gives me it gives me 12,400. 0.09 per point. The same thing you do for the same thing you do for the lighting. You get all the sockets, you measure all the cables, then you divide it by the point. You get what the average point is. You put it here. If it is 8, it is 8. Then it gives you the cost per point. Then your labor cost. You know what your labor cost is, and your labor cost also can vary depending on your cost data. If over time you have done some projects, you kept your cost data, you can as well say the cost I use for cabling this house, piping this house is this amount. So, and if I divide it per the the points, all the point, including the socket, including the switches and all, I am getting, say, the cable and the piping and all, I'm getting, say, 100 naira per meter. I apply there, multiply by whatever, it gives me what my cost is. Multiply, it gives me what my cost is. So as you can see, this is how all applies. The only one that the is different is the cooking gas. No, sorry, the cooker unit, the AC, and the water heater. Because these two items, they take their supply directly from the DB. There is no looping from one point to another. So we go to drawing, let's say, in say this toilet, or is this toilet, I have water heater, which is this, a water heater here, and I have an AC here, and my DB is here. So I just take my cable right away from my DB, from my AC to my DB, and drop it inside my DB. I take my cable from the water heater directly, drop it into, because the star blocks, of course, the capacity of the star block for these items are different. I drop it there. Then I take the AC from this point to here. We have two AC. Even though we have two AC, normally if it is a power, you loop from this to this, then you take from here. But there are two ACs. You take this one directly to the DB. You take this one directly to the DB. Once you take it directly to the DB, you take it directly to the DB. You take all directly to the DB. You add them together, average them. It tells you what you are going to apply. You are going to apply as how many meters you are going to apply to the cost for 1 meter. Then the same thing you do for the kitchen, which is the cooker unit. The same thing from the kitchen to the DB. You get what the cost is. If it is a 40 meter, is a 40 meter. If it's just one cooker unit that is there, it is 40 meter. You apply 40 meters. If it is 20 meters, you apply 20 meters, and that is the price for that point. I've been able to do justice to this topic, but if you are still having some challenges in terms of understanding my explanation, you can hit my page, subscribe to my page, through some questions. Then I can answer your questions, and possibly, if the need be, I can do a second video to further explain where your worries are. Thank you.